In lesson 22, we're going to look at finding the area of quadrilaterals. We're going to look at three different types of quadrilaterals. First one is parallelogram. Once again, quadrilaterals, four-sided polygon. A parallelogram is opposite sides are always parallel. Well, the area for a parallelogram is equal to base times height, or length times width. Now, we've seen this in a square. Right, we see base times height, but key note is to always know that the height right here always has to be perpendicular to the base. So in a square it always is. But if you have a rhombus, or sorry, parallelogram, we got parallel opposite sides. Our base is easy to find, but our height is always perpendicular. So if it gave a problem like this, area of parallelogram equals base times height, we would multiply 15 for our base, and our height is the 8. All right, not the 6. So that can confuse people, but 15 times 8, and that would be 120. 120 would be your area, and then whatever unit you use. That is how you find the area of parallelograms. The main thing is to make sure that the base is always perpendicular, or the height is always perpendicular to the base. Now let's look at a trapezoid. The formula for, well, just so you remember what a trapezoid is, a trapezoid has one pair of opposite parallel sides, and then the other opposite pair is not parallel. So you got one pair of parallel sides. Area of a trapezoid is this formula: 1/2 times the sum of base 1 plus base 2 times your height. So let's try to plug this in. It's pretty straightforward. Base 1, either one of these can be base 1. It really doesn't matter. I'm going to use 20 as base 1, 28 base 2, but notice if you add them together, it's going to be the same thing anyway. And then our height. Height, once again, always perpendicular. Now this one, it just gives it to us that this is perpendicular. But so our height here is 6. Now we do order of operations. 20 plus 28 is 48. And then from here, 1/2 of 48 is 24 times 6. And 24 times 6 would be 144. And it is area, so it's inches squared. But that's how you do trapezoid. No real curveballs there. The last type of quadrilateral we're going to look at is a rhombus. We need to find the area of a rhombus. A rhombus is a quadrilateral with, all right, 4 congruent sides. The formula for a rhombus, if you don't have the base and height, is 1/2 times D is diagonal, so diagonal 1 times diagonal 2. So let's look at some examples. Example 3a actually gives us 9.5 as a base, and then for the height, it gives us 9, because it actually writes it like this. It gives us 9 for the height. There's a perpendicular sign. So we don't have the diagonals. We don't know the measures. Well, that's fine. We also know that the area of a quadrilateral is base times height. So we can simply plug in 9.5 for base, and then height of 9, and then we get 9 times 9.5 would be 85.5 centimeters squared. So there's area, but that's just to show you that you could use actually either for a rhombus. And then the next example, it actually does give us diagonals. It gives us 11, and 11 is the whole diagonal, and then 30 is the whole other diagonal. So we use our formula: 1/2 times 11 times 30 for the area, I'm going to do 1/2 of 30 is 15 times 11. 15 times 11 would be 165 inches squared. So those are those are 3 different quadrilaterals and finding the area for those. Very, very easy math. Just got to know the formulas to plug them in.